Now, in these last four examples of the day, we're going to look at some special cases that arise from some of these systems. We're going to solve them the same way that we did before. In this first one, in letter I notice that the x terms, when adding the two equations together, cancel out. So I'm just going to add those two together. Negative 3x plus 3x cancels. Y minus y also cancels. So what we have left on that left side is just a 0. And then on the right side, negative 5 plus a 5, that is also equal to 0. So what happened was, in this case, both of those variables canceled out. Both of them were eliminated. And we ended up with something that was always true, which means that these lines are always intersecting no matter where you are on the line. So these two lines are the same line. They are always intersecting. So what that means then is then we have infinitely many solutions. Now for the second example, I'm going to do the same thing again. The x's eliminate right away. So we're just going to add these two equations together. But what happens again is that both the x and the y's eliminate. And adding the constants together on the right side, we end up with 16. Now in this case, we end up with something that is never true, which means that these two lines never intersect, so they are parallel. So therefore, they never intersect. There is no point of intersection. So we end up with no solution. Now for these last two, we're going to have to do a little bit of work to get a variable to eliminate. For example, here we have 2x, so we want to turn this into negative 2x. Now nothing happens to the bottom equation. And the top one, how do we turn negative x into negative 2x? We multiply it by 2. So we're going to multiply the entire top equation by 2. We have plus 2y is equal to negative 4. Now what happens here is the x's cancel, but so do the y's. So we're left with 0 is equal to negative 4, something that is never true. So therefore, these two lines never intersect. They are parallel. So we have no point of intersection or no solution. And finally, in the last one, to get the x's to eliminate, the number that 12 and 4 both go into is 12. So we want to turn the top into a negative 12x, so they become eliminated. The bottom equation stays the same. That doesn't change. The top equation, how do we turn the 4x into a 12x? Negative 12x, we multiply everything by negative 3. So we subtract 3y, and that's equal to negative 18. And when we add these two together, both the x and the y cancel out. Negative 18 plus 18 is 0. So we get down to something that is always true, which means that these two lines are always intersecting no matter where you are on the lines. So therefore, we have infinitely many solutions. Now, one comment about this, you can't really write all real numbers for these because X and Y both have to lie on these two lines. So that's why we say infinitely many solutions as opposed to all real numbers. Now, in videos that you'll watch tomorrow, we will solve systems of inequalities by graphing instead of systems of equations.